If you want to learn about Demurrage and the ERGO blockchain, then this video is for you. Let's jump in. Demurrage. What is it? Why is it? How does it work? And can it be abused? According to Grok AI, demurrage refers to a cost associated with holding an asset. On ERGO social media, it is referred to as storage rent applied to UTXOs. More on these later, that haven't moved for over 4 years. Now, after all, a blockchain is essentially an immutable ledger maintained on the nodes of the chain, and if the data on the chain is to be preserved forever, wouldn't it make sense to compensate the miners who keep a copy of the full node to store this data? Regarding the Ergo blockchain specifically, once emissions have stopped, demurrage ensures that the total supply of ERG will remain constant at 97,739,924 ERG. This differs from other chains that employ an inflationary emission schedule, or, as in the case of Bitcoin, theoretically fixed, but potentially deflationary, since coins are effectively removed from circulation due to lost wallet keys, as well as the accumulation of dust, a term used to describe UTXOs that contain less Bitcoin than the transaction fee needed to spend them. Now that we have covered the what and the why of demurrage with regard to Ergo, we should hit the pause button before discussing how it works. This is because before you can understand how demurrage works, you first need to have some basic knowledge about UTXOs. UTXO is an acronym that stands for Unspent Transaction Output. It is the data structure that Bitcoin uses. Technically, Ergo uses an extended UTXO structure, which extends the functionality of the UTXO model. We don't need to get too far into the weeds on this. And going forward, we will refer to the concept simply as UTXO. A UTXO is essentially an entry in the blockchain's data structure, which is maintained on the nodes of the chain. It can be thought of as a box which can hold currency, metadata, smart contracts, NFTs, or Ergo native tokens. However, it must have a minimum amount, 0.001, of ERG. The exact details of how a UTXO can be used as an input in a transaction, get spent or consumed, and generate output UTXOs as well as a transaction fee can be covered in another video dedicated to this topic. For now, just know that as you use the Ergo blockchain, transacting, trading, and possibly mining, you will accumulate UTXOs with varying contents. These UTXOs, holding your on-chain assets, reside in the blockchain database and are controlled by the cryptographic keys of your wallet. Now that we have a basic concept of how our on-chain assets are stored as UTXOs in the Ergo database, we can tackle the issue of how demurrage works. UTXOs that have been stored untouched for approximately 4 years can become subject to demurrage, also known as storage rent. The idea being that these UTXOs are not being used in fee-generating transactions, yet their data must be maintained on the node, and it is not unreasonable to apply a small storage rent for this service. I say small because the storage rent is around 0.14 per UTXO. The amount is technically a fixed rate per byte of data stored in the UTXO. And I say approximately every 4 years because the interval is actually based on block height. And since a block is mined roughly every 2 minutes, the math works out to about 4 years. You may wonder how the Ergo blockchain knows that the UTXO has remained untouched for 4 years. Embedded in the UTXO data is the time and date the UTXO was created, and therefore its age can be tracked. A few specific examples will help to shine some light on the demurrage process. In our first example, consider this UTXO with exactly one ERG. If left untouched after 4 years, demurrage will result in this UTXO being spent with the resultant transaction creating a new UTXO containing 0.859 ERG, along with the storage rent of 0.14 ERG plus the transaction fee, which can vary, but we will assume for this example is 0.001 ERG going to the miner that mined the block containing this transaction. Similarly, a UTXO containing an NFT along with one ERG, untouched for 4 years, would be spent with the resultant creation of a new UTXO containing the NFT and a reduced amount of ERG and the deducted storage rent and transaction fee going to the miner. As a thought experiment, you might wonder how long it would take for a UTXO containing one ERG to be completely consumed due to storage rent alone. Well, if we divide the one ERG by the value of 0.14 ERG per storage rent event, we would get about 7.14. And since you cannot have a fraction of an event, we will round this up to 8. Since 4 years go by between events, we find that it would take about 32 years for the UTXO to be completely spent due to storage rent alone. Therefore, it might take a while, but ERG stuck in UTXOs associated with lost keys will eventually be reclaimed by miners, keeping the supply of ERG constant over time once emissions are complete, neither inflationary nor deflationary. In our next example, we will consider the case of a UTXO with some ERGO native tokens and a minimal amount of ERG. Note that this amount is less than the storage rent of 0.14 ERG. If left untouched for 4 years, with demurrage applied, this UTXO would be spent, and since the ERG in the UTXO is not enough to cover the storage rent, the miner can claim the new UTXO that is created containing the ERGO native tokens and the small amount of ERG. You may wonder how this situation can be prevented since most wallets do not list the individual UTXOs, but rather the total amount of ERGs, NFTs, or Ergo native tokens. The wallets therefore have the ability to generate a message informing you when there are UTXOs that are at risk of having storage rent applied. You are then presented with an option to consolidate your UTXOs, which essentially spins and regenerates the UTXOs. Once finished, you will see that your wallet displays your original holdings, minus the small transaction fee the chain requires for any transaction. Or you have the option of sending your UTXO to yourself, which again would spend it and generate a new UTXO with the same contents, resetting the clock on that UTXO. The final example we will examine concerns dust, a term applied to UTXOs that contain such a small amount of ERG that the cost to spend them exceeds their actual value. A partial list of their origins would include transactions, spamming or dusting attacks, as well as mining rewards. The accumulation of these dust UTXOs can lead to chain bloat, weighing down the chain and increasing storage requirements for the blockchain node. Ergo solves this issue through demurrage. As these UTXOs age, the small amount of ERG within them can be subjected to storage rent, which would be combined with the transaction fees from mined blocks, consolidating them into new UTXOs claimed by the miners, thereby lightening the chain and reducing storage requirements. We can now address our final question. Can the demurrage process be abused in such a way as to cause financial harm to everyday users of the Ergo blockchain? Some have wondered if it is possible for blockchain developers to secretly increase the storage rent and thereby claim large amounts of ERG from unsuspecting wallet holders. In order to address this concern, we must dig into the details of the Ergo protocol. Let's begin with the fact that the Ergo blockchain is open source and its code is readily available for examination by anyone, so secret changes are not possible and any proposed changes would be noted and discussed by the community. In addition, the storage rent is controlled by the storage rent subprotocol, which sets parameters for the process, including a minimum and maximum amount that can be charged, with the minimum set at 0 nanoergs per byte of data and the maximum capped at 2,500,000 nanoergs per byte. Currently, the amount is set at 1,250,000 nanoergs per byte, which is about 0.14 ergs per standard UTXO. Moreover, the subprotocol limits the amount the current storage rent can be changed, with increments set at 25,000 nanoergs. The interval between storage rent adjustments is also constrained by the subprotocol, with the interval set at 4 years. During that time, the miners on Ergo can vote to change the storage rent with the change implemented at the end of the cycle. The current cycle began on February 18th, 2022, and will end on February 18th, 2026. And lastly, any adjustment would have to be agreed upon by a supermajority, that is, greater than 90% of the miners, a vote which would be conducted on chain after extensive debate by the community at large, and only implemented after submission and review of any relevant Ergo improvement protocols, EIPs, by the developers and following exhaustive trials on a testnet. In summary, there are ample guardrails surrounding the demurrage process. And there you have it. Now that you have thoroughly explored the demurrage process on the ERGO blockchain, you can turn your mind to other important questions such as, what is empty space made of? Why exactly 97,739,924 ERG? Why am I not outside right now playing with the dog?